Okay, well hello everyone, welcome to day 4 of 30 Days Wild. My name is Ben, this is my new flatmate Tylo, and I don't think he's going to stick around for very long, but I thought I'd introduce him anyway, because he's taking up an enormous amount of my time nowadays, and he's gone already. But what I wanted to do today, you'll notice for 30 Days Wild that there is a tail coming out of the back of my head. You'll notice that I'm inside, which does seem like I'm cheating a little bit because the whole point of 30 Days Wild is to get outside and have a look around. But today it is rather grim outside. I'm looking out of my window and it's drizzly and windy and kind of gross. And I was thinking a lot recently about seeds and plants and how they sort of grow and how they happen and what they are. And that's not really something I can show you with a camera. So I thought I'd just have a really quick little chat about seeds to start with and a little bit to finish with about photosynthesis as well, because that's something that was always a bit abstract and overly complicated. I don't think it needs to be as complicated as it seems to be. Now, start off with a seed. Now, seeds are absolutely amazing things. The biggest seed in the world, I've just been reading, I've got this fantastic book here called Seeds. Nice and succinct, it tells you everything, or rather that way. It tells you everything you need to know about what the book's going to be about, and it's absolutely full of really beautiful diagrams and plants and little things showing you a whole side to the world of plants and seeds that we don't really see because it's so tiny. But not all seeds are tiny. In fact, the biggest seed in the world, according to this book, possibly, is the Seychelles nut, and that weighs 20 kilograms. 20 kilograms for a seed. A big duck, like a big duck, weighs 4. So you'd need 5 big ducks in a bag to make one seed for the Seychelles nut. And then some seeds are so small that they're not even called seeds, they're called dust. Orchids, for instance, they make really tiny seeds that are so small they're called dust, and they're completely microscopic. You can never really see them with the naked eye. So they are amazing, but I was trying to think about what actually a seed is and how it works, because they're amazing things. Like, so there's something called the Millennium Seed Bank at Wakehurst, which is part of Kew Gardens, the botanical gardens at Kew. It has a whole collection, thousands and thousands of species of plants in seed form, and it's basically keeping them, well, for a rainy day, in case they go extinct out in the wild. And they've got thousands of species, but they're able to keep them cool and keep them dry, and they can live for hundreds and even thousands of years. How does a seed do that? How can it stay alive for such a long time? How can it stay dormant for that long? Well, it's amazing. So basically there are 3 parts to a seed. On the outside, there is a shell. Really nice, strong outer shell, which protects everything on the inside of the seed. Now, mostly what's inside the seed is something called endosperm. And endosperm is basically a combination of oil and protein and sugar and things like that. Basically very high energy food, but it's very dry. And this is the point. Because the third part of the seed, it's only a tiny little part of the seed, is the embryo. And that's a tiny plant, and it has tiny seed leaves and tiny seed stem and a tiny seed root. So basically a tiny little plant inside every single seed, which is amazing. But the seed basically acts like a giant sponge. When the seed gets into the soil and it starts to get wet because it starts to rain, then it absorbs water and expands, and it gets nice and soft, kind of like a sponge in your sink. When it's not been used, it's quite dry. When you put it in the sink, it gets all soft and squishy. Well, this is like the endosperm. When it gets all soft and squishy, then the baby root can start to eat the endosperm. And that means it gets bigger and bigger and eventually breaks out the bottom of the seed. Now, this can happen quite quickly, within sort of a few hours or a day, certainly. And it can break out of the seed and start growing down into the soil, the substrate. And that's where it's going to take on even more water, it's going to take on nutrients, it's going to take on more and more stuff. And then, and only then, does the baby seed leaf and stem start to grow. And they grow in the completely opposite direction because they're making their way up to the soil surface. Now, the reason they're trying to get up to the surface is because they're trying to find the sun. Because only once it breaks out of the soil and once it's growing up into the sky, it's getting the light. And that's exactly what photosynthesis requires. It needs sunlight. Now, photosynthesis is a weird process because it was always taught to me in a fairly strange, it always seemed to be quite an abstract way of explaining it. It was always told in a very sort of formulaic way, and sort of like it was an equation, like carbon dioxide plus water plus sunlight equals oxygen and sugar. As if that meant anything. And it didn't mean anything. What does that mean? That's nonsense. I mean, it's not nonsense. It's a good way of explaining it, but it's a pretty boring way of explaining it as well, I think. Now, someone actually asked me, a friend of mine a little while ago, why are leaves green? Seemed like a very simple question, and I thought the answer would be quite simple as well. I just explained photosynthesis. But I realised that photosynthesis is something you can literally see every single day of your life. You look at it every time you look at leaves, every time you look at trees, every time you look at grass, and it appears green, because that's what colour they are. That is literally, you are looking at photosynthesis right there and then in that moment. You're looking at it happening. And that is because when you think of the rainbow, that's the full spectrum of lights. You've got the red end and you've got the blue end and you've got the greens in the middle. Now there's a lot of energy at the blue end and there's a lot of energy at the red end, but there's not very much energy in the green, and that's why plants don't use it. So they take the blue light and they take the red light, and the green, they don't really need that. It's too low energy, so they reject it, they fire it back off. So when you're looking at a plant, you're not just looking at it being green, you're looking at it not being red or blue. And that means it's using the energy from there to make glucose, which it powers itself along with. And it has this wonderful relationship, the top part of the plant with the bottom part, the roots, which started growing before the top part ever started. And that's basically plants. So that's photosynthesis. And I just thought it was absolutely wonderful to have this little realization that you can literally see photosynthesis every day of your life when you look out at a tree or a plant or some grass. And I think that's a lovely way of looking at it. Anyway, that is my little spiel. I'll let you get on with your day. I'm very much looking forward to finding out what's going to happen on day 5 of 30 Days Wild. And yeah, thank you very much for watching, and I hope to see you very soon. Boop!